Okay, let's check out some examples of exponential density functions. And again, I wrote the formulas to the right. And first off, what is an exponential density function? Well, it's one that fits into this model here. Okay, if f of x is in that form, it's an exponential density function, and it has these two properties. The expected value is 1 over k, and the variance is 1 over k squared. So first, let's just kind of take a look at this and do a generic problem. If I have this exponential density function, what is the expected value? Well, it's 1 over k. Expected value is 1 over k. So all we really need to do is find out what k is. Well, looking at that formula, I chose a fairly simple one, but they don't get much harder than this, right? If k were 3, just make sure that works. So I'd have 3 here and a negative 3 there, which we do. Perfect. So e of x is just 1 over 3. And the variance is 1 over 3 squared, which is 1 over 9. Okay, pretty straightforward. Sometimes, actually, the further we get, the easier things simplify and come out to be. So once again, we're not going to look at why this is true, just how to use it. All right. In the next example, we're taking this scenario in this factory, there were 2 accidents per day. The time between the accidents has an exponential density function, and the expected value is 1/2 a day. So we expect that every half day, 12 hours, right, there is an accident, and that there are 2 per day. Now, side note, I think they should revise their safety plans, right? I mean, that's a lot of accidents. I don't know how large this factory is, but man, I wouldn't want to be the manager reporting 2 accidents every single day on the job. Probably wouldn't want to work there either in that case. Anyways, let's set this up. So part A is find the probability the time between 2 accidents will be more than 1/2 a day, but less than 1 day. Right? So we're now in probability form, the probability that x is between 1/2 and 1. Okay, and that equates to probabilities go to integrals, right? We integrate continuous random variable, which an exponential density function is continuous. So 1/2 to 2, we need the function though. All I know, so I'm kind of jumping again, all I know is the expected value is 1/2, right? So let's do a little bit of side work here. If the expected value is 1/2, and I know that the expected value formula is 1 over k, I can kind of just look at that and tell you k is 2, right? But you can cross multiply. K times 1 equals 1 times 2, so k equals 2. So now I know the function, it's 2, right? K is 2, e to the negative 2 x dx. Right? So we're still integrating our function, but we need to define the function using the information provided. All right, now integrate this. Remember the integral ke to the kx is just e to the kx, or use u substitution. So really quick kind of review, right? If u is negative 2x, then du is negative 2 dx. Well, I have a 2, not a negative 2, right? So, and if you want, you could change all these bounds. I think this one's straightforward enough. I just need a negative here, but I can't just put it there, so negative times a negative is positive. So as long as I put it out front, then we're good. So that is just negative, because that negative out front, e to the negative 2x. Right, we had integral eu du. And I know the integral of u to u is just e to the u. So since u was negative 2x, there we go. And again, we can change the bounds if we want. Kind of up to you. We're going 1/2 to 1. Let's leave that negative out. And we have, substitute 1, we'd have e to the negative 2 times 1, right? E to the negative 2. Subtract e to the negative 2 times 1/2, or e to the negative 1. And distributing that negative then, I'm going to go and rewrite it with this one first since it's positive, e to the negative 1 minus e to the negative 2. And, you know, in math, we'll go ahead and call that a day. But probability, like, what the heck does that answer mean? I'm going to be lazy. Like, I don't know. Just plug it in a calculator. I forgot to do that ahead of time, and I'm not going to pause the video to just substitute something in a calculator. But again, in math, it's perfectly acceptable to leave it like that. That is like the exact form. Okay. Part B here. Find the probability the time, so same scenario, same expected value, that the time between the accidents will be less than 8 hours, or 1/3 of a day, right? 8 hours is 1/3 of a day. So the probability that x is less than 1/3, that's the same as integrating 0 to 1/3. We have that same integral, and in fact, I mean, we already did all this work, right? Like, I know this is the result, but I'm going to go in and write it again. So 2e negative 2x dx. Okay. So using our substitution, we know it's going to be negative e to the negative 2x. Range that from 0 to 1/3. So now, again, let's factor out that negative. We have e to the negative 2/3 minus e to the 0, which is 1. So distribute that negative, we'd have 1 minus e to the negative 2/3. And again, just use your calculator, see what that probability comes out to. I wanted to do one more side note. What if we had asked this, the reverse of this question? What if we asked probability it's more than 8 hours? What would that change? So instead of the probability x is less than 1/3, what if I asked the probability x is greater than 1/3? Well, now we'd have this indefinite integral, right? 1/3 to infinity, which is okay. I mean, we learned how to do this. But instead, because the probability of these two, we call them complements, right? The events like less than 8 hours and more than 8 hours, those are the only two possibilities in this scenario. They should add up to 1. So instead of this, like, you can do this, or that's equivalent to 1 minus the probability of x is less than 1/3. Right? We take the result we just got and take it away from 1. So therefore, we could just do 1 minus the result we just ended with. And 1 minus 1 is 0, so we just get a positive e to the negative 2/3. Now, if you had done it this long way, and use the limits, right, in indefinite integrals, you should still get the same result. Okay, last example here. So life of a light bulb, the lifetime in weeks of a certain brand light bulb has an exponential density function, so it's telling you it fits the form we were just looking at. 80% fail within the first 100 weeks. Find the average lifetime of the light bulb. So now the average lifetime, the expected value, right, that's what we don't know. So using that formula above, we don't know the 1 over k. Okay. So we don't know k, really, right? And also we have that, it fits in that form, ke to the negative kx. So let's get this set up. This time we are given the probability x is less than 100, right, within the first 100 weeks. Less than or equal to really wouldn't matter in all of these, because that remember area, right? Area of a line is 0. Anyways, so we get 0.8, 80%. So I know that is equivalent to integrating 0 to 100. Again, I don't know k, e to the negative kx dx. All right. Using similar reasoning as above, I need eu du, so I need a negative here, which means I need a negative there. All right, so integrating this, we just get a negative e to the negative kx, 0 to 100, 0.8 equals that. Right, we could just move that negative to the other side and have negative 0.8. So now I'm just substituting 0 and 100 for x. So we'd have e to the negative 100 k, right, k. I'm plugging in x is 100. I still don't know k. Minus, well, e to the 0 times negative k is just e to the 0, which is 1. So if this is 1, right, negative 1, I'm going to add 1 to the other side. My point didn't follow. That's a 0.8, right? So 1 minus 0.8 is 0.2 equals e to the negative 100k. And now we use properties of logarithm, ln both sides, right, to get rid of an e. I'm going to just move it right here. So we get ln of 0.2 equals negative 100k. And now, I mean, we have to use a calculator. I don't know ln of 0.2. So divide by negative 100 and just plug that in. Plug that into a calculator. For now, it's still exact. ln 0.2 divided by negative 100. Okay, but we get approximately 0.016 for k. So the expected value, right, let's go back to the problem, find the average or the expected value. We're not quite done. Is e to the x over 1 over 0.016. And again, a calculator, that comes out to about, I'm going to say about this whole time, 62. So what does that mean? The expected value, x is in weeks, right? Lifetime in weeks, is on average, the lifetime of the light bulb is about 62 weeks on average.